Hello, welcome to section 8.2. So in this section we're going to continue with our working with radical expressions, but we're going to start encounter radicals of things that are not perfect squares or perfect cubes, but we want to simplify them to the simplest expression. So basically we need to break up our number or our variables in a product. We're going to have different factors, and we're going to take out the factors, apply the radicals, the square roots or the cube roots on the factors that are perfect squares or perfect cubes, and then leave a part inside the radical that can't be simplified anymore. Okay, so let's look at this example. So these are done a couple of ways. So one way is that if you can recognize that there's a perfect square in there, multiplied by something else, or a perfect cube, you can rewrite your number as a perfect root or exponent times something else, and then simplify. But if you can't recognize that, you can do it with the factor tree, just looking at the factors and to identify things that are perfect squares. Okay. Alright, so let's look at this. So square root of 98. Okay, so the first way I mentioned, I noticed that 98 is 49 times 2. Okay, so I'm watching out for perfect squares. So it's like, can I possibly take that number and write it as a perfect square times 2? And I want perfect squares because I'm taking the square root. This is the index of 2. Alright, once I notice that, I say I'm going to split it up. I'm going to do square root of 49 times square root of 2. This part is 7, but this part can't be simplified anymore. So you want to kind of get the possible value there, right? That you can't pull out any more perfect squares or perfect cubes and so on out of that radical. Then it's in its simplified form. Okay, so this is like method 1. This is usually quicker, so it's nice, you can recognize. Method 2 is to use the factor tree. Right, so you want to kind of make a prime factorization of your number. So we have 98. You're going to write it here. And then you're going to divide by factors, by prime factors. So we're going to start with 2. And then go to 3, to 4, to 5, to 7, and so on. And you want to divide out all the prime factors out of it. So if I divide by 2, I get 49. Okay, circle the prime factor. 49 I can break up as 7 and 7. They're both prime, which means they can't be divided anymore. So we circle them. Okay, so 98 means 2 times 7 times 7, which is 2 times 7 squared. Okay, so we're going to go back to our square root. The square root of 98 is square root of 2 times 7 squared. We're going to split it up, square root of 2, square root of 7 squared. Alright, now because this divides by this is going to be 7 to the 1, and the radical for this part disappears. Alright, but this one can't be simplified anymore. And we write it like that. Okay, so usually with smaller numbers, typically you can do it a little bit quicker with the first method, but if your numbers are larger, the factor tree is really useful. Okay.